Hello again. Okay, so in this section, we are covering trig functions of real numbers. Okay, so 5.2, trig functions of real numbers. Okay, so let's just kind of recall. Hopefully you remember this when you had your right triangle trigonometry, right? Okay, so this is a right triangle, and suppose this is our angle theta. Okay, um, so in relation to uh, theta here, we have our hypotenuse. Okay, and in relation to theta, this leg over here would be the opposite leg, and this leg down here would be the adjacent leg. Okay, if I were talking about the angle up at the top, then those would be switched. The one down below would be opposite that angle. Okay, so it's very important that you are aware of which angle are we talking about and which leg is opposite from that and which one is adjacent. Okay, and then hopefully you remember Sohcahtoa. Okay, so maybe you learned it something, some sort of little um, poem. I can't remember. Oh, I remember. Somebody teaches it saying some old hippie caught another hippie tripping on acid. Okay, maybe that's not appropriate. Okay, anyway. All right, so this here will just help you remember the trig ratios. Okay, S stands for sine, C stands for cosine, T stands for tangent. And then the O, H, and A stand for these three things that I just wrote on the triangle: opposite, adjacent, and hypotenuse. Okay, so according to that the first three letters there for SOH, S-O-H, that means that sine of theta is the ratio of the opposite, O, over H, hypotenuse. Okay, cosine, C for cosine. According to CAH, that would be the ratio of the adjacent side to the hypotenuse. And if I do tangent of theta, then that would be TOA, so opposite over adjacent. Okay. And then we have the other three trig functions, which take the reciprocal of these. So here we have cosecant, which is the reciprocal of sine. So it's going to be hypotenuse over opposite. And then we have secant theta, which is the reciprocal of cosine. So that's going to be hypotenuse over adjacent. And then we have cotangent, which is the reciprocal of tangent. So that is going to be adjacent over opposite. Okay, so if you took trig, then you probably have this memorized still. Very basic for trigonometry. If you don't have this memorized, you better hurry up and memorize that. Okay, so that is something that is expected of you if you've taken trig. All right, so we're going to be using those ratios. So let's take a look at that with a circle. Not necessarily um, the unit circle, but a circle with some sort of radius r. Okay, So let's go ahead and draw this circle with radius r. Okay. And let's go ahead and draw that on x and y axes. And so we have some point over here, x, y, right? Some terminal point there, right? And this here has some sort of radius, not necessarily 1 anymore, but some sort of radius r, okay? And what happens is I can draw my right triangle here, where that point is that y value together with this x value here, right? This is the x value that we're talking about for that point, and the y value, x, y, okay? And now I have formed a right triangle and this angle, okay? So if I use the ratios written above, Sohcahtoa, right? Then here, according to my right triangle and those trig ratios, here I'll write it. Okay, so then if I take the sine of this angle, whatever angle this is, then it's going to be opposite. So that's going to be a y value over hypotenuse, which is my r, the radius, the hypotenuse. Okay, if I do the cosine of that angle, well, it's going to be adjacent. So adjacent to that angle is x, and the hypotenuse, which is the radius. And if I do the same thing with tangent, so tangent theta is opposite over adjacent. So opposite is going to be the y value. Adjacent is the x value. Okay. And then I can get my other three by taking the reciprocals of these. Okay. So if I do cosecant, that's the reciprocal of sine. So that's going to be r over y. If I do secant theta, that's the reciprocal of cosine. So it's going to be r over x. And if I do cotangent, that will be the reciprocal of tangent. So that's going to be x over y. Okay. So let's go ahead and do this example where we have to find the sine of t, the cosine of t, and the tangent of t. T here is going to represent that angle, okay? All right, so suppose that I have this one here. Okay, so I have this point, and that's all I know. I know this x value, and I know this y value, right? Okay, so then what happens is, and you don't have to draw this, but you know, it's helpful. Here, let me show you. So 1, 2, 3. Okay, so 3, 4, 3, 1, 2, 3, 4. Okay, so that's kind of where it's at. Okay, and if we draw our little right triangle here, right, we know this is 3, this is 4, and then we can figure out this hypotenuse, which is 5, right? It's the 3, 4, 5 triangle. You can find that side here. Let me just do it. You can use Pythagorean theorem. So to find that radius, right? That's just going to be 3 squared plus 4 squared. Okay, so r is equal to 5. Okay, so once you have all of those values, you have the x, the y, and the r, then you can apply this here. Sine is y over r, cosine is x over r, and tangent is y over x. All right, so let's do sine t. This is t. Okay, so sine t is going to be opposite, or y value, over your r value. Cosine is your x value, which is 3, over your r value. And tangent is your y over x. Okay? Let's go ahead and do another one. So suppose that we have this point, -4, 7. So again, you don't need to draw the right triangle and plot it or anything like that, because really, based on this right here, to find the sine, cosine, and tangent, we only need to know what the x value is, the y value, and the r value. Okay? And if they give you a point, then you already know the x value and the y value. Okay? So to find the r value, we just use the Pythagorean theorem. Okay? All right, so r squared equals -4 squared plus 7 squared. So r squared equals 16 plus 49. So r squared equals square root 65. Well, 65 and then square root 65. Okay, and we'll just leave it like that. Okay. All right, so we know the x, the y, and the r. Okay, and we know that sine is y over r. So then that's going to be 7 over square root 65. Okay, so like me personally, I don't care if you have radicals in the denominator. I don't require that you rationalize them. WebAssign, I'm not sure. Okay, so if you need to, if you plug this into WebAssign for the answer and it says it's wrong, then try rationalizing it. So multiply both the top and bottom by square root 65. So try doing this, entering this one instead. Okay. All right, cosine t is going to be x over r. So our x value, -4, r value, square root 65. And again, see what WebAssign wants you to do. Okay, and then tangent is y over x. So that's going to be 7 over -4. Okay. And if it says to like find the exact value, that means just leave it in radical form. Don't use decimals. Okay. All right, so let's take a look here. Find the exact value of each trig function. Okay, so again, whenever you see this, if you see this on WebAssign, it means no calculators, no decimals, just leave it in radical form. Okay, radical form, no decimals. Okay. All right, so suppose that we have this one, sine of 5 pi over 6. Okay, so again, figure out which quadrant that is. Okay, figure out the quadrant that's in. Okay, And so just like what we were doing in the last section, okay? So if you need to cut this up, right? This is pi, 2 pi. It's cut into 6 pieces. So, all right. So 6 equal pieces. And you go 1, 6, 2, 6, 3, 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6. Okay. So this tells me that you're in quadrant 2. Okay. So this tells me that I am in quadrant 2. And my reference angle, my reference number is pi over 6, which is associated with these numbers. Square root 3 over 2 and 1/2. Okay. All right. So here, so sine of 5 pi over 6 is going to be associated with the y value. Okay. So over here, sine of 5 pi over 6 is going to be, okay, so it's going to be the 1/2, but always check to see what quadrant you're in. The y value there is positive. So sine of 5 pi over 6 is going to be the y value, because this is the unit circle. This is off of the unit circle. Okay, so this is off of the unit circle, so it's going to be y over r, so 1/2 over 1, which is just 1/2. Okay. Because sine of 5 pi over 6 is equal to the y value over the r value, which is 1/2 over 1. Okay, which is just 1/2. Okay, let's try another one. All right, find cosine of 5 pi over 6. Okay, so 5 pi over 6, again, this puts me in quadrant 2, and my reference is pi over 6. And so that tells me that it's associated with this point, square root 3 over 2, 1/2. Okay. And so cosine of 5 pi over 6 is x over r. My x value in quadrant number 2, x values are negative, and my radius here is 1. Okay, so that's just going to be square root 3 over 2. Kind of a lot to think about. Okay, so, or keep track of. All right, so let's do this. Tangent of 5 pi over 6. Okay, so we've already kind of did a lot of the work. We know it's in quadrant 2. I know my reference number is pi over 6, and you've memorized that. That is associated with square root 3 over 2, comma 1/2. Okay, and in quadrant number 2, my x values are negative. Maybe we should just do that. Okay. So tangent 5 pi over 6 is y over x. And we know what those two are. It's 1/2 over negative square root 3 over 2. Okay. And then I'm going to multiply both, I'm going to multiply by 2 over 2. Okay. And that will cancel out my denominators there, leaving me with negative 1 over square root 3. Again, if WebAssign wants you to rationalize this, then your answer would be negative square root 3 over 3. Okay, but either one of those are fine with me. Okay, I'm going to have you try this next one. Find the exact value of each. Okay, here, I'm going to have you do 2 of them. Let's do cosine negative 5 pi over 3. And then let's also do sine of 5 pi over 4. Okay. Okay, so go ahead and hit the pause button, and I am going to work these out myself. Okay, so thirds. So your half circle is cut into thirds, and we're going in the opposite direction. So 1/3, 2/3, 3/3, 4/3, 5/3. So my point is here in quadrant 1. Okay. Okay, so we are in quadrant 1, so we don't have to worry about negatives or positives. My reference number is 1/3 pi over 3. Okay. And we know that that is associated with 1/2 square root 3 over 2. Okay. And we don't have to worry about anything being negative. Cosine of negative 5 pi over 3 is going to be my y value over r. R is 1. Okay, so it's going to be, not y value, x value over r. So that is going to be 1/2. 1/2 over 1, because my radius is 1. Okay, and that's it. Okay, sine of 5 pi over 4. Okay, so my half circle is cut into 4 pieces. I'm going to need more, so let me draw the ones down here. Okay, and then so 5 pi over 4, so that's 1/4, 2/4, 3/4, 4/4, and 5/4. Okay, so my point is right here. And okay, my point is right there. So I am in quadrant 3. Quadrant 3. And my reference number is 1/4 pi. which is associated with square root 2 over 2, square root 2 over 2. But I'm in quadrant 2, so that is going to be negative on the x and the y. Okay, so then that tells me that sine of 5 pi over 4 is y over r, but r is 1. Okay, so my y value here is negative square root 2 over 2. Okay. All right. So I think there's a little bit more. Okay. So, yes. Okay. So let's take a look at these here. All right. Let's take a look at a different kind of example, but very similar. Okay. So here we go. Okay, so let's go ahead and find the exact value. So that means leave it in radical form, no decimals. Find the exact values of the 6 trig functions. So that's sine, cosine, tangent, cosecant, secant, cotangent. Okay, the 6 trig functions of t with the given information. Okay. All right, so let's try this one. Sine t equals 3 over 5. Okay, so that's all you know right now. And you also know that the terminal point is in quadrant 2. Okay, so this is all you're given. Okay, so I would suggest you do draw these because it's very helpful to figure out signs. Okay, so you're in quadrant 2. And let me write these down. Okay, so this is important that you're in quadrant 2. And then here, we also know that this here is your y value, and this here is your r value, because sine is y over r. Okay? All right, so let's go ahead and draw that. Okay, so we're in quadrant 2, so somewhere in here. I don't know where. Okay, but I do know that my y value, this value right here, is 3. And I also know that this value, my radius, r, is 5. Okay. And so this is the one I don't know. Okay, but I can find that using Pythagorean theorem, right? So x squared plus 9 equals 25. You probably know what the answer is going to be. Okay, so x is equal to 4. Okay, so now we know that that is 4. But is it really 4? Because look where this is. And what do we know about x value right here? That's going to be a negative 4. So that's why I say draw this out so you can keep track of the negatives and positives and whatnot. All right, so now that we have the full triangle, we can do sine of t. This is t. Okay, sine t, cosine t, tangent t. So sine t is y over r. Okay, it's y over r. So what's our y? 3. Oh, we already know. 5. Here, hold on a second. This is a little slow. All right, so we already know sine t is 3 over 5 because it's given. Okay, cosine t Okay, so cosine is x over r. So what's my x value? -4. What's my r value? 5. Tangent is y over x. So that is going to be 3 over -4. Or if you just want to say -3 over 4, that's fine. Doesn't matter we just know the number is a negative number. It doesn't matter whether you put it on top, in the middle, or down below with the 4. We know that 3/4 is negative. Okay. All right. And then the other 6 are just the reciprocals of these. So cosecant will be positive 5 over 3. Secant will be -5 over 4. And cotangent t will be -4 over 3. And that's how you would get all 6. Okay. Why don't you go ahead and try this one? Tangent t equals, this is a good one. You'll have to figure out who's negative. I'm going to put it right there in the middle. Who's negative, x or y? All right. And here's something. Here's another clue. Cosine is positive. Okay. So go ahead and find the 6 trig functions. Okay. And hopefully you hit the pause button. Okay, I'm going to go ahead and do the answers here. So we know that tangent is y over x, right? So we want to know who's the positive one here, who's the negative one. So here, this is kind of a big clue. Cosine, which is associated with the x value, is positive. So then that must mean that the y value is negative. Okay, so let's go ahead and give that negative to the, to the y value. Oh yeah, we said y value. Okay. All right, so we know that this is what we have. My x is 4. 1, 2, 3, 4. My y is -3. So I'm over here. Okay. If I do my little triangle, okay, then I have this, 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 and we know this is 4. This is -3. That's my 3, 4, 5 triangle again. Radius is always positive. Okay. So radius is 5. So now I have all of my numbers for all 6 of my trig functions. So sine t is y over r. So that's going to be -3 over 5. Cosine t is x over r. So that's going to be 4 over 5. Tangent t is y over x, and that is -3 over 4. Okay, and then the other 3 are just the reciprocals. So cosecant t is -5 over 3. Secant t is 5 over 4. And cotangent t is -4 over 3. Okay, so hopefully you guys got those right. Okay, and then there's one little thing that I need to do here. It's I need to mention the Pythagorean identities. Okay, so Pythagorean identities. Okay, so these are going to play an important part when we start looking at some other sections later on down the line. Okay, so let's just take a look at the unit circle again. You have some point over here that's x, y, right? And the radius is 1 unit circle, right? And if I draw my right triangle here, then I can apply, um, this is an x distance, this is my y distance, right? Okay, and I can apply the Pythagorean theorem here, and I get that x squared plus y squared equals 1 squared, right? Okay, so x squared plus y squared equals 1 squared, which is what we saw before, right? Okay, and but we have some values here for x and y, because take a look. So we're dealing with unit circle, so r is 1, right? And we know that sine, here, I'll call this theta, okay? Or you know what, we've been using t. Let's use t. Okay, so let's call that t. All right, so then we know that sine t is y over r, so y over 1, okay? And we also know that cosine t is x over r, so x over 1, which is just x, right? Okay, so we have values for x and y. So I can plug those into here. Okay, so here, then, I get x is cosine, y is sine t, and I get this. Okay? Another way to write it with squares, with the exponents, is like this. That's another way to write it. Okay, so if you took trigonometry, you should be familiar with this one. It's usually written as sine squared over, it's usually written as sine squared plus cosine squared equals 1. All right, so that's our first one. Okay, now if we divide all of those by cosine squared, let's go ahead and do that. Okay, so if I take that equation and divide all by cosine squared, right? So if I do that, divide this by cosine squared, this, and this. Okay, so then I end up with 1 plus tangent squared equals, well, the reciprocal of cosine is secant. So here is Pythagorean identity number 2. So we got that by dividing that first one by cosine squared. Let's take that first one, cosine squared plus sine squared equals 1. And let's divide all of that by sine squared now. And let's see what we get. Okay. So if I divide everything by sine squared, and sine squared, okay, then cosine over sine is cotangent. Sine over sine is 1. And the reciprocal of sine is cosecant. So there's your third Pythagorean identity. Okay. All right. So there you have it. That is 5.2. Okay. If you have any questions or if you want me to cover any of these topics a little more in depth, just send me a message.